here we are, we're going to have project 623 going up to project 640, which is the strobe light. So we're starting off with the AM radio with power LEDs. That's how it appears in the book. Here it is on the board. So we've looked at the AM radio circuits before in past projects. Really the only big difference with this one is we have the red and green LEDs there to kind of show us the power output coming from the speaker that kind of flicker with the output. It's pretty much the same again circuit as we've seen with AM radios before. We got 6 volts here. Now the LEDs are actually running off this 3-volt battery pack by itself because they get their power off of this rail here. This is the actual 6 volts when you do it through this section, which goes through our amplifier IC coming out to our speaker. We have our variable resistor acting as a volume control for it. We have a couple of capacitors here all being used for filtering the signal coming from our high frequency IC here, which is then being controlled via our variable capacitor with our A1 antenna in parallel with it, which of course is receiving the AM radio signals. And then we got our R5 resistor doing some current limiting there, and the same thing with our amplifier IC with resistor 4 here. So when we turn the circuit on, both our LEDs light up. Let's see if I can get our thing adjusted. And as I'm tuning through the frequencies on the variable capacitor, you can see our LEDs flicker because of the output from the speaker here corresponding with how much current's going through the LEDs there. Again, I don't think I can get any actual stations here because I have a lot of interference around this from electronics and stuff, which is all the noise you're actually hearing in it. Yeah, I'm just picking up noise and not really getting any stations. But anyway, you get the idea. It's just like the previous AM radio circuits, but this time we have the pair of LEDs there to kind of show us the power output through the speaker and amplifier IC there. So that's pretty much how Project 623 is. So we're going to move on to Project 624, which is the Space War IC recording. So here we are with Project 624, the Space War IC recording. There it is in the book, and here it is on the board. So we've got our 6-volt supply here, and that's going to our D3 diode. And before that we have our NPN transistor, so that is connecting our speaker and 6-volt lamp across it, and that's being controlled via the output of our recording IC. So whatever output it's going to have there, it's going to turn on and off our NPN transistor, and we'll be able to hear that through the speaker while it's being limited by our 6-volt lamp. In our recording IC we have our press switch and toggle slide switch here. So of course this one is for playback and this one is for recording. And then continuing on, we have our Space War IC, which is being driven by our little green LED there, and we'll see that glow ever so briefly, indicating that there's power going to the Space War IC, plus it'll flicker as the Space War IC works. We have our output selections based on what's grounded here, and then our output is going to the input of our recording IC, and it's being dropped by our 100 ohm resistor so that it's not overloading the input side of our recording IC. So when we plug this in, I don't know how well the camera may be picking it up or not, but the green LED comes on very dimly, and it does flicker a little bit because the Space War IC is on and active right now, creating an output, but we can't hear it because it's being fed into the recording IC that's not turned on right now. So we're going to record the output from the recording IC or spacewar IC I should say, into the recording IC. So there's our beep to indicate recording is started. And then there's our 2 beeps to say that it's finished. And we press the press switch, we'll get the playback stored in the recording IC that is recorded from the spacewar. So there's the Space War's output stored on the recording IC, and now it's playing, of course, one of the built-in songs there. And as usual, we can press the press switch to stop it, and we can play it again with a different pre-recorded song after. As that works now, we can take one of these and change it, and now we will change the output of the Spacewar IC using a different connection point. So if I tell it to record this time, we should have a different set of audio being recorded this time. Sort of. It's usually supposed to change it, but you get the idea there. And you don't want to keep this circuit powered up with the batteries and all, because the Spacewar IC is not controlled by any of the switches here, so it's always drawing power with the circuit there. So you don't want to leave it unattended with batteries connected or anything like that, because it will slowly drain them. So that's just something to keep in mind. So that's project 624. So now we're going to move on to project 625, which is the LED flasher. So here we are at project 625, the LED flasher. There it is in the book, and here it is on the board. So we've got 6 volts again, all being controlled by our slide switch. It then feeds both our red and green LEDs here. And then we have a little bit of a feedback thing going on here with our amplifier IC. We have our variable resistor controlling some of the input to the amplifier IC, along with our 10 microfarad capacitor going across it to our LEDs here. And then we have our PNP transistor here, which is going to be turned on and off. And all this combined is going to make the LEDs flash at a periodic rate, which then we can control with our variable resistor. Again, controlling the feedback to our amplifier IC, and this controlling the level of charging to our capacitor, which then of course will also affect how often our PNP transistor turns on and off. So when we turn the circuit on, it briefly charges up, and you see that both our red and green LEDs flash. And as this system works, you see that the green LED is starting to go out and the red LED is speeding up. And that's because it's building up a charge in the capacitor here, and then the charge kind of floats at the lowest setting there. So we don't really see the green LED for the rest of it, but now it's more of in a steady state there. So you see our red LED is now pulsing on and off, and as we change our variable resistor, again we affect the feedback, and by doing that we can change how often the LED flashes, because now it's charging and discharging at a much faster rate. And we can bring that up even more. See, it starts to slow down, so it's about the highest point. If you go all the way up, the LED goes out, because it's pretty much going so fast that it's not really showing us flashing anymore. And of course, we can continue adjusting the rate with our variable resistor there. So that's how project 625 works, and now we're going to look at project 626 and 627, the LED flasher with sound. So here we are with project 626 and 627, the LED flasher with sound. That's how it appears in the book, and there it is on the board. Now, I'm going to be up front. I always test my circuits after they're built from the book here before doing any recording, and I'm going to say up front that this circuit does not work with how they've got it in the book here. Yes, things may be a little different, but electrically the circuit is exactly how they have it in the book here. And what it's supposed to do is it's supposed to flash with having the transformer here, and we hear the sounds from the speaker, it's supposed to basically flash much faster than what the previous Project 625 had, but it doesn't behave like it's supposed to. See, I've just turned it on there, and nothing's happening. Of course, sometimes it will work for maybe half a second, or other times it'll make kind of a squeal. And the thing there, I don't know if that's because well, that's because we got this big capacitor, which is the wrong type on. Which are we looking for? C2. Now, of course, this is actually supposed to be all the way up to the top. So that's the part of it that seems to work. Yeah. Do a quick discharge of that. Disconnect cat and this PNP transistor. Because I think the capacitor charging and behavior of the amplifier IC is causing some problems. Yeah. So, I can't really show Project 626 or 627 because simply it doesn't seem to behave as they say it's supposed to according to the book. So this is a case where you, the viewers that are looking through these, need to build 626 and 627, because I've also tried this with the battery boxes and I get the same results. So I'm very curious if other people's project here building this, if it actually works or if it's got the same problem, because we have had issues in previous projects where it's not printed in the book correctly, and so the circuit doesn't work as it's supposed to. And I think this is another case of that, because unless I really look at this, I don't exactly have the time at the moment going through these to examine what's going on with this one. So we're just going to have to skip these two projects. So in that case, that's going to bring us to 628, which is the stepper motor. So here we are, Project 628, the stepper motor. There it is in the book, and here it is on the board. So we got our 6 volts being controlled via our slide switch here, and then we got a couple of things happening on the board here. We have our motor with the fan, and that's going into the emitter of our PNP transistor, which is then connected across our transformer here, and its output is being stepped up so we can get it out to the speaker here. So as the motor turns, we'll hear the signals coming out of the speaker. But then you see we have our base of the PNP transistor connected across our NPN transistor, and we've looked at this setup before. This is effectively a Darlington transistor setup. So the NPN transistor is controlling the current to the base of the PNP transistor there, so it's basically a scaled up effect. So it makes the transistor more sensitive. And on that, with the base of our NPN transistor, that's coming from our R4 resistor, which is then being controlled by our variable resistor above it. And we have our 100 microfarad capacitor across the base of our NPN transistor and the collector of the PNP transistor. And that's one of the key things that's going to factor in how this circuit works. So when we turn the circuit on, you see that our motor pulses there. It turns about maybe every half a second or so, where the variable resistor is right now. And what's happening is that every time this pulses, what's our capacitor here is charging up. So the resistance across it is low. When the capacitor nears full charge, its resistance then goes high. And when that happens, then our NPN transistor can then turn on because the current's not being taken away from the base there, which then of course turns on our PNP transistor, and that allows current to flow through our motor. And again, it goes through the transformer, so we actually can hear the pulses coming out of the speaker there. And as we adjust the variable resistor, the interval between each pulse or step of the motor decreases, so it actually steps faster. And that's because we've lowered the resistance to our capacitor here, so it's charging up faster. So if we go the other way, now we increase the resistance to this capacitor, so now it takes longer for it to charge up, and thus we have a longer interval between each step of the motor. And there are some fun things you can do. Of course, you can put different size capacitors on here, all the way from C1 to C5, and that will let you see how changing the value of the capacitor affects the delay on the step there, whether it makes it longer or makes it shorter. And it also changes the frequency of the sound we will hear out of the speaker if we were to do that. So that's how Project 628 works. So we're going to move on to 629, which is the crazy music IC. Here we are, Project 629, the crazy music IC. There it is in the book, here's on the board. So again, we have 6 volts with our slide switch. And again, the main part of this is the music IC. We have both our green LED and regular diode there going into inputs 2 and 3 of our music IC, so that it'll make it play and repeat. And our output goes, of course, to our speaker. And then we have a little more interesting stuff happening here. We have our relay below the music IC, which it's feeding into right now. It connects across our 2.5 volt, 3 volt lamp here to ground. And then we have our relay. And then when the relay closes, it then connects the music IC directly to ground, bypassing the 3 volt lamp here. So that, of course, will affect the music IC's output. And as for the relay is being controlled by all the stuff over here. So we have our variable resistor going down into our 10,000 ohm R4 resistor, and that then goes down into the base of our NPN transistor. And the NPN transistor is controlling the base of our PNP transistor. So again, we have a bit of a Darlington transistor setup here, but this time it's being limited by our R2 1000 ohm resistor, so there's a little bit of limiting going on there. And then we have our 10 microfarad capacitor going across the collector of the PNP transistor and the base of our NPN transistor there off of resistor 4. And then we have another capacitor that's in parallel with the PNP transistor here, our 100 microfarad capacitor. And then that goes down, to, of course, to our relay. So as this section over here charges and discharges, it will, of course, allow current to pass through the relay contacts here, making it open and close depending on our setting on the variable resistor here. And of course that will connect the music IC directly to ground when it closes, again bypassing the lamp here, so that changes the effect. So with the variable resistor where it is, it sounds pretty normal. But as we start changing the resistance, we now start changing how these capacitors charge, and thus our relay flickers on and off here. And you can see how the music IC is being affected by this. So that's how Project 629 works. So now we're going to look at Project 630 and 631, the stepper motor with sound. Here we are with Project 630, the stepper motor with sound. There it is in the book, and here it is on the board. So again, we still have 6 volts. It's very much like the previous circuit, but this time we have the motor here involved with the relay. So everything here is pretty much the same, except that we've changed over to a 470 microfarad capacitor, so we've scaled up the capacitance here on this side. And so when this circuit activates, whatever we have set on the variable resistor over here will control the charging and discharging of the capacitors over here, which in turn will energize and de-energize the relay. And what the relay does here is it connects and disconnects the motor to ground here through the speaker. And because the speaker is in series with the motor, because of how it's set up, we'll hear the motor through the speaker here. And of course the motor will step faster or slower depending on where the variable resistor setting is. So if we turn it on now, so you can hear the relay clicking, and it got stuck on there. Down here. So you hear the relay clicking on and off there, and every time it closes, the motor spins some, and we get a little bit of its audio through the speaker. And as you've already seen, as you adjust the variable resistor, you can speed up or slow down how quickly these charge, and of course that determines how quickly or how often the relay opens and closes. So that's how Project 630 works. Now Project 631 has us take the speaker out, and it wants us to use L1, which is the 3-volt lamp. But in my past experiences with something like that, if you've got 6 volts, use the L2 6-volt lamp instead, because that way you minimize the risk of burning out your 3-volt lamp, which I've already had happen in previous projects because of that. So when we turn the circuit on this time, so instead of the speaker there now, the 6-volt lamp lights up every time the relay closes, again with the motor in series there. And just like before, depending on where the variable resistor is, again determines the interval of how often the relay closes. So that's how Project 631 works. And now we're going to look at Project 632, which is the Police Siren with display. So here we are, Project 632, the Police Siren with display. There it is in the book, and here it is on the board. So we got 6 volts with our slide switch again. It's all going through our D3 diode, which is feeding our 7-segment LED with a couple connections. And then it's feeding both our music IC and alarm IC, with our alarm IC's output going to the speaker, and then also providing some output for our D7, the 7-segment LED, while the music IC is helping to drive the alarm IC, basically connecting it, and then as the music IC plays, then the alarm IC will run and we'll get the output there. So we turn on the circuit, we hear the alarm IC play back there, and we see the letter P displayed on the 7-segment LED. And as you saw there, it briefly went out and started again, and that's because of our music IC here. So our music IC is providing a feed for the alarm IC, but also because we have the hold function enabled, the music IC repeats, and that keeps the alarm IC going as long as this is replaying. So that's how Project 632 works. So now we're going to move on to Project 633 and 634, which is the Oscillator Alarm. So here we have Project 633, the Oscillator Alarm. There it is in the book, and here it is on the board. So again, we still got our 6 volts controlled by our slide switch, and we've got our oscillator circuit part over here, like we've seen in previous projects. It's controlled via our variable resistor, which then controls the opening and closing of our relay here, which is across our alarm IC, with its output going to our speaker. And we have a little visual component with our green LED there. So we power the circuit on. It briefly turns on because we don't have any oscillation going with the circuit till we move this over some. And we do that, you can hear the circuit oscillating slowly there. And every time the relay closes, it connects the alarm IC to ground there, and it momentarily makes it sound. And by, of course, changing the variable resistor, we change the oscillation rate of the circuit. So that's how Project 633 works. Now Project 634 has us take our red LED and put it across the relay like that. And that's similar to our previous project, so now the alarm IC will always be connected to ground through the LED here, but then the relay will occasionally close and connect it directly to ground, bypassing the LED. So that's how it normally sounds, but then when it starts oscillating, we now occasionally just bypass the LED connecting the alarm IC direct to ground there, which changes the sound output of the alarm IC there. And of course you see our LEDs reflect that change too. So that's how Project 634 works. Now we're going to move on to Project 635 and 636, which is the tapping U3. So here we have Project 635, the tapping U3. There it is in the book, and here it is on the board. So we have our oscillator circuit as before, just a little bit reconfigured. Again, controlling our S3 relay switch, and that's operating our Space War IC, which we have our speaker as the output for, and we have our 6-volt lamp across it as well. So we'll see the lamp oscillate with the circuit there. And of course, as the circuit oscillates, it affects the audio output of the Space War IC. So we've already got the variable resistor set in the middle there. When we turn it on, you can hear that relay tapping. Our little 6-volt lamp is pulsing, and you can kind of hear the chirping sound from our speaker out of the Space War IC. And of course, as we change the frequency of the oscillator circuit, we can slow that down, or we can speed it up. So that's how essentially Project 635 works. Now 636, we're going to put the motor across these points here, and then with the motor on there, it's going to put some load on there, and that's going to affect how the audio and the oscillation circuit works here. See, now the Space War IC sounds quite a bit different because now the motor is putting some additional load on there. So it almost sounds like a chirping bird there, or something like that. But anyway, that's how Project 636 works. So now we're going to move on to Project 637, which is the adjustable beeper. So here we are at Project 637, the adjustable beeper. There it is in the book, and here it is on the board. So we have our 6 volts as before. We don't quite have the same usual oscillator circuit, but we still have an oscillator circuit over here using our 100 microfarad capacitor going into our resistor, into the base of our PNP transistor, which then is going on and off into our transformer here, along with our whistle chip in parallel with our C1 capacitor, and then we can adjust the frequency of the oscillator circuit with our variable resistor here, and then the output from the transformer is being stepped down and going into our speaker there. So we've got our variable resistor all the way up to the top here. We turn the circuit on. We get kind of a rapid chirping sound, and as we move the variable resistor down, we can speed that up and change the frequency of it. So that's how project 637 works. So now we're going to look at project 638 and 639, the Electronic Meow. So here we are at project 638, the Electronic Meow. There it is in the book, and here it is on the board. So we've got several capacitors across here, along with our kind of oscillator circuit again, with our PNP transistor, with our variable resistor controlling the frequency of the oscillation. We have two of our little capacitors here in parallel across our transformer, which is stepping down to output to our speaker. And then we have some more capacitors over here that store a charge using our slide switch and then go into there. And then we turn the circuit on and off with our press switch there. We also are only using 3 volts this time. We don't have 6 volts, and it's all being limited by our 100 ohm resistor here. So we leave that off, and we have this down here. See, we get that sound there. But when we add our capacitors in the circuit, not how well that comes through, but of course changing the frequency can be done with the variable resistor. And you can hear that sound ramp down as the capacitor is discharged, depending on how much current is being provided through our variable resistor. So that's how project 638 works. Now 639 is having us use the photoresistor in place of our 10,000 ohm resistor here. So let me take that out, put the photoresistor in its place. Yes, sir. Variable resistor. And now the photoresistor, we can manipulate the resistance, how much light goes into it. I'll just turn that back on there. And of course, by changing how much light goes into the variable resistor, photoresistor, we can of course change the oscillation of the circuit there, and how fast those capacitors discharge. So that's how project 639 works. And now the last one, project 640, is the strobe light. So here we are, project 640, the strobe light. There it is in the book, and here it is on the board. So we're back up to 6 volts again, and we have a little bit of an oscillator circuit using our NPN transistor with our variable resistor here to control the frequency of the oscillation with our little transformer here. And then we have our LED, which is outputting the capacitor that we're charging and discharging. But we don't have any kind of thing running off the transformer here. We're just energizing and de-energizing the winding in there. So when we turn the circuit on, you see the LED will start off bright, but it will start to oscillate when we bring the variable resistor down there some. So you see it's flashing, and as we bring the variable resistor down, we can make it flash faster and faster. And if we go the other way, of course, it gets slower and slower. And that, of course, has to do with the charging and discharging of the capacitor, which in turn also turns on and off our NPN transistor there. So that's project 640, and that concludes this set of Snap Circuits videos. get on there. Ugly. Ugly, but it will work.